In a potentiometer arrangement, a cell of EMF 1.25 volt gives a balance point at 35 centimeter length of the wire. If the cell is replaced by another cell and the balance point shifts to 63 centimeter, what is the EMF of the second cell? It is kind of very easy one. So what is the first cell given? It is epsilon 1 is given as 1.25 volt, and for that we had the balancing length L1 as it was 35. That is going to be, we need to find epsilon length of balancing length. It is given as 63 centimeter. So if we have this kind of a thing, directly we have the equation for the potentiometer. Epsilon 1 divided by epsilon 2 should be equal to L1 divided by L2. So direct substitution. What we want here is epsilon 2. I will rearrange it for epsilon 2. It will be equal to L2 divided by L1 into epsilon 1. So L2 is 63, L1 is 35 into epsilon 1 is 1.25 volt. So this is my answer. The number density of free electrons in a copper conductor estimated 8.5 into 10 to the power of 28 per meter cube. It is given as per volume. How long does an electron take to drift from one end of a wire 3 meter long to its other end? The area of cross section of the wire is 2 into 10 to the power of minus 6 meter square, and it is carrying a current of 3 ampere. N equals 8.5 times 10 to the power of 28 per meter cube. Length of the wire is given as 3 meter, and A equals 2 into 10 to the power of 6 meter square. I equals 3 ampere. I equals to N A E VD is distance by time. And what is the distance that electron has to travel? It is going to be the length of the wire, which is given here. So I am going to take it as L. And what kind of velocity I am talking of? It is the drift velocity. So instead of writing this Vd here, I can replace it by L by T. So what I can do here is I will be equal to NAE. Instead of Vd, I will write it as L divided by T. Shift this T to the left hand side, I can go to the right hand side. So the equation becomes T equals NAE L and whole divided by, that is I. Now if I substitute the values, N is given in here, it is 8.5 times 10 to the power of 28. Area is also given, it is 2 into 10 to the power of minus 6. Charge of electron is 1.6 into 10 to the power of minus 19 into 3, and whole divided by, the current is also given as 3. Now why I did this is because of this cancellation which I can do here. There is a 3 in the numerator, there is 3 in the denominator, I can cancel it. So 8.5 into 2, that is going to give me a 17 into, there is a 1.6 into, I can take care of the powers. There is a 10 power plus 28, 10 power minus 6, so 28 minus 6, that is going to give me 22, and there is a minus 19, and that is going to give me 10 to the power of plus 3. There is nothing in the denominator. We have to deal with only these 3 numbers. So it is only 17 into 1.6 into 10 to the power of. This should give you something number like 2.73 into 10 to the power of 4. So this is my time. Now, what you could do here is you can just put seconds there. Answer for this one will be 7 hours 33 minutes and some seconds you are going to get. The seconds parts will not be necessary, maybe like 10 seconds, 12 seconds, 14 seconds. It can be something between 10 to 20 seconds you may get, because depending on the variation, because there is a 10 power 4 here, we are not taking what is the exact number of seconds, and that is the way it is given. So the time will be equal to 7 hours 33 minutes and some maybe 10-11 seconds. You are going to get the answer as